This video is about graphing an inequality, and for our notes, we'll understand a few key things. First of all, to graph an inequality, we carry out the following steps. First, we graph it as if it's an equation. We've been graphing lots of equations, and so we're going to utilize all the things we already know about those. However, there's one twist here. We're going to use a dashed curve for the strict inequalities and a solid curve for the inclusive, less than or equal to, greater than or equal to. So that's what's new about the graphs. Otherwise, we're still graphing equations that we already are familiar with. And then secondly, there's another step to graphing an inequality, and that is we have to decide where or which side of the graph represents the solution. There's an actual region, a two-dimensional region that is the solution, and we can usually find that by using test points. And so once we use a test point to find out which side is true, we simply shade that side of the curve. Let's try an example where we want to graph the inequality that is as follows. 2x minus y minus 9 is less than 0. Now again, we're pretending that this is an equation for a second. So let's even just say we're going to pretend that this is 2x minus y minus 9 equals 0. Okay, we know it's not actually equals here, but we're just going to pretend that because then it will look very familiar to us. In fact, this is just a linear equation. If I add y to both sides, I'll end up with the equation y equals 2x minus 9. Well, that's just a line that's in slope-intercept form. We could go ahead and graph it. Now, going back to the original symbol, because it was strictly less than, we're actually going to use a dashed line for this graph. So on our graph paper, we probably don't have enough grid lines for a y-intercept of negative. Now let's see, 1, 2, 3, 4, 5, 6, 7. Let's add a couple more here, 8, 9. Okay, so our y-intercept is way down at negative 9. Our slope is 2, so I can go up to right 1, up to right 1. You can keep walking that to get the slope. And it only takes a couple points, but if you do a few of them, you'll be sure where the line is. And we want to make a dashed line connecting all of those points. Okay, so again, that's really nothing different from on any of the line graphing that we've done previously. But this time it's an inequality, so it's dashed. And then secondly, we want to test a point. Now, we just have to pick any point that's not on the line. Of course, my favorite is 0, 0, because plugging in zeros is easy. To test that point, we have to go back to the original inequality, not the equation that we were pretending with. The equation was only there to help us get the graph. Now we need to test it using the inequality. So we're plugging in 0 for x and 0 for y, which means is 2 times 0 minus 0, that's like the 2x minus y, minus 9. Is that less than 0? We're not sure. This is our test to find out. Well, simplifying it would tell us that negative 9 is less than 0, which is actually true. Since the test point came out true, we're going to shade the side of the line where the test point is, which would be everything above this line. So we'll go ahead and just shade that in. Now, if the test point had come out false, it would simply tell us to shade the opposite side. So really one test point is enough to know which side to shade on, because it either turns out true or false, and that tells you which side of the line to shade if you only have two sides, right? Or even a curve would work the same way. All right, so there's our inequality, and it's graphed completely with the dashed line and the shaded side of the graph. So really the picture is our solution to this. Let's try another example where we want to graph the inequality. This time it's given as x squared plus, and then y minus 2 in parentheses squared is less than or equal to 4. Now remember, we're going to pretend that this is actually an equation. If I wrote it that way, it'd be x squared plus, and then y minus 2 in parentheses squared equals 4. Okay, it's not actually equals, but we're just pretending for the moment so we understand what the graph should look like. Now, if you take a look at this equation, this may look familiar. It's the graph of a circle, and it has the center at 0, comma 2. So it's been a while since we've done circles, but that's how we can find the center from that equation. And the radius can be found on the other side, which you see is r squared, so r must be 2. Okay, well we can easily graph a circle with those properties. So let's go ahead and put a center at the point 0, 2. And if the radius is 2, I can extend 2 units in each direction and then do my best to connect them and form a circle. Now this is going to be a solid circle thanks to that original inequality symbol of less than or equal to. So I'll go ahead and draw a solid circle connecting all those points. We've done that before. And now we need to test a point to know, do I shade inside or outside of the circle? We just have to pick any point that's not on the circle itself. And unfortunately, 0, 0 looks like it's on the circle, and that's our favorite test point. Let's actually pick, how about the center of this circle? The center is not on the circle, it's in the middle of it. When I say on the circle, I'm talking about on the actual curve. So if we test that center point, which we already had found was 0, 2. Of course, we test it by plugging it in the original inequality. And so I'm plugging in 0 for x and 2 for y. That would tell me 0 squared plus, and then inside for y I'm putting 2, so 2 minus 2 squared. We're wondering if that's less than or equal to 4. Well, that would be 0 plus 0, so 0 is less than or equal to 4. Actually, that is true. So since our test point is true, we shade where it is. It happens to be inside a circle. So a circle is not something you're either above or below. You're either inside or outside of it. So since the test point was true inside, we would shade inside the circle. And so again, the picture is the graph on the picture is the solution of this inequality.